too. And let's get started. Okay, so the unit that we're in is about solving systems using matrices. So there are some matrix operations that we have to get comfortable with. All right, so this is a pretty easy unit. Most people feel pretty comfortable with this stuff, but you gotta learn how to do it. So again, if you do not have notes up to this point, then you need to watch the video and get those notes completed so that you know what's going on. All right, we're gonna find what's called the determinant of A. So this is matrix A right off the sheet, and I'm going to find the determinant of it. The abbreviation we use is DET, and the notation we use is vertical bars. So we have the same matrix idea, but it looks like absolute value signs instead of brackets. This always means determinant. Okay? To evaluate a 2 by 2 determinant, it's very, very simple. We multiply 1 times 5, 1 times 5. We multiply 3 times negative 2, 1 times 5, 3 times negative 2, and we subtract the results. So it's, for this determinant, it's 5 minus negative 6, 5 minus negative 6, so the value of that determinant is 11. The determinant is just a number, always. Okay, let's look at B, or I, problem I, which is the determinant of B. Okay? All right, so how do you find the determinant again? We know how to do this. We multiply 6 times negative 4. We multiply 0 times 3, and we subtract. So what's the value of that determinant? Negative 24. It's easy. Just gotta remember how to do it. Okay? Now we're going to find the determinant of C. C is bigger. We're going to find the determinant of that matrix. So everybody sees that it's bigger, right? So here's how you do a big one like that. We take the first 2 columns. So 1, 0, 1, and negative 1, 3, 4. And we recopy them exactly in order with negatives, everything. Don't change a thing. Recopy this one first, this one second, right at the end of your determinant. Then you start right here, and you multiply those 3 numbers together. So multiply, and you get 0. And then you multiply these 3 numbers together, and you get 1. And you multiply these together, and you get another 0. Okay, so I created this big thing by tacking on these 2 columns, and I multiply that diagonal, multiply that one, and add all that up and get 1.
What do you add that one?
Okay, wait, be careful, hang on. We're not done. Now we turn around and go the other direction. So now we're going to multiply these, and we get 6. And we multiply these, and we get negative 4. And we multiply these, and we get 0. and we total those up and get 2. Now, Jeff, what do you think I'm going to do with those 2 numbers? I did this direction, and I did this direction. Now, what am I going to do with those 2? I'm going to subtract them. 1 minus 2. So the value of that determinant is -1. Can you kind of see, groupies, that that right there is just a bigger version of this? We do this minus this, right? Well, it's just more numbers, but it's this direction minus this direction. Okay? All right, let's see, determinant of D. Uh-oh, can't do the determinant of D. Anybody want to take a wild guess what's wrong with D that does not allow me to find its determinant?
Rows and columns aren't equal.
Rows and columns aren't equal, which means it's not a square matrix. In order to find a determinant, you have to be square. All right? If you're going to find a determinant, you have to be square. And D is not square. What are the dimensions of D, by the way? 2 by 3. Thank you, sir. 2 by 3. 2 rows, 3 columns. In order to find the determinant, you have to be square. All right. Oh, number 3 is another practice problem with this big determinant. So let's see if we can figure out how to do this. Remember, we know how to do it. Let's see if we can remember. There she is. Okay? So, Donovan, what do I do first? And I do them in exactly the order they are. So 3, 6, -1 comes first, and then 0, 1, 5, right? And then I go diagonal, always starting here. This is where we always start. So down I go, -6. Down I go, 0. Uh-oh, this is a big one. Down I go, 150. I'm going to add those up. So if my arithmetic's right, I got 144. Yep.
Oh, go the other way.
Then I go the other way. So start down here now. So I got -5. Oh, another big one. 45 and 0. So I got 40.
Subtract 1.
And then we subtract. Always, always, always subtract. So it's 144 minus 40. So the answer will be 104. Remember, the value of the determinant is always just going to be a number. And it can be any number. Donovan? It won't necessarily say find the determinant. If you see this notation, if you see those vertical bars around like a matrix thing, that means find the determinant. Okay?
Now, does it matter if you go which way you do what?
Yes.
Okay, so you have
Because
to go down
subtraction is not commutative.
first. Okay.
So 40 minus 144 would not be the right answer.
Right. Okay, so you have to go down
first. And kids, a lot of times that is a point of confusion. Just remember, if I ask you, when you wrote this down on your paper, isn't this the first number you would write? Start with the first number, always. That's where the multiplication begins. All right. So now we've got determinants figured out. So if you were to walk in here next time, is that tomorrow? If you were to walk in and I would say, okay, take out a half sheet of paper and do this determinant, would you be able to do it?
Yes.
Okay, that was like a hint. Okay, on number 4. It says find A inverse, and we're using the same matrix as we had before, which is this. All right, so this is another thing you have to know how to do. You have to know how to find the inverse of a 2 by 2 matrix. Now, back in the old days, when I got to see you every day, we learned how to find the inverse of bigger ones. We're not doing that. Those we're just going to do on our calculator. But you still have to know how to do the inverse of a 2 by 2 by hand. Okay? It's a 3-step process. Really simple. Step 1. This means inverse. Okay. Step 1. Find the determinant. Okay, so you tell me, I think we already did this, but anyway, do it again and tell me, what's the determinant of this little matrix?
5 plus 6 versus 11.
It's going to be 5 minus negative 6, so it's going to be 11. All right, hang on to that number. We're going to go to the second step now. We'll come back and get that in a second. The second step is we're going to create a new matrix. It is called the adjoint. You don't need to know that, but it has a name. This is a real thing. And it's going to seem kind of random how we create it, but these two numbers, look where I'm pointing, flip-flop them. So put the 5 here and the 1 here. Whatever they are, don't change a thing, just flip-flop them. And then the other two numbers, if they're positive, make them negative. If they're negative, negative, make them positive. In other words, change their signs. So this is going to become a negative 3, and that's going to be a positive 2. Don't move them, just change their signs. So these two get flipped. These two get their signs changed. Okay, last step. Take this new matrix that you just built and divide every number in it by the determinant. So your inverse is 5 elevenths, 2 elevenths, negative 3 elevenths, and 1 11th. Those are the 3 steps. Now we're going to do the exact same thing with matrix B. Okay? All right, step 1. Let's see. Sophia, step 1.
First solve it, so negative 24 minus 0.
Yep. So she said solve it. I'm fine with that word. What she really means is find the determinant of it. So the determinant of it turns out to be negative 24. Okay. All right. Gabe, step 2. It's that kind of random weird thing. We're going to make a new matrix. So these guys flip. So negative 4 and 6. And these guys change sign. Well, 0 is just 0, but that's going to become a negative 3. Everybody okay with that? And then Kelsey, last step.
Divided by the determinant.
So all of these numbers get put over negative 24. Now, our last problem didn't require require any simplification. This one is, we always have to simplify. And all those fractions reduce. So our final answer, B inverse, the inverse of B, is going to be 1/6, 1/8, 0, and negative 1/4. Is he?
Oh, never mind, I saw some negative 24.
You okay with that? Don?
The determinant ever be 0?
Yes, and in fact, yes, that absolutely can happen. And when that, what are you thinking, Donovan?
Because, I mean, just you put the, I only thought of it because you put the 24 under the 0.
Exactly.
And then I was like,
You see where, he looks like he's sleeping, but he's wide awake. Donovan's saying, what if the determinant was 0, Mrs. Ford? We would have a problem, wouldn't we? That would mean our matrix had no inverse. That actually happens. It's not a good thing for us, but it happens, and it's called when that happens, it's a singular matrix. When a matrix is singular, that means its determinant is 0. And all kinds of wild and wacky things happen. We'll see some of them coming up, but you're right. So Donovan's question, I think, ultimately is, if I'm doing this problem, Mrs. Ford, and you've asked me to find the inverse, and I do the determinant, and it works out to be 0, what do I put down as the inverse? No inverse. Right, no inverse. It's a non-invertible matrix. It's a singular system. Yep. Great point, Donovan. Great. All right, let's get our calculators out. Now we're going to find the inverse of a big one. All right, so everybody's got a calculator out. And you know how cranky I get when you're not paying attention to me. So I need everybody to get a calculator out, turn it on, and then press the buttons I tell you to press. Okay, so unless you already know how to do this, I need you to press the buttons I tell you. All right, so the first thing I want you to notice is, right here, we didn't do the calculator work the other day, did we? Okay, all right, so we know where the matrix button is. Right here it says matrix, right above this button where I'm pointing right here with this finger. So press second matrix. And anytime you want to put a new matrix in, and we are going to put in matrix C at the top of that page where we started, we're going to put in matrix C. Anytime you want to put it in, you got to click over to edit in that top row in your matrix menu and press enter. The first thing that the calculator wants to know is, how big a matrix are you going to be putting in? Well, what are the dimensions of matrix C? 3 by 3. So we just press 3, enter, 3, enter. Now, if you already have stuff in there, don't worry about it. You just type right over it. Okay? Don't worry, just type. Now you've got 9 slots to fill, and we just start filling them. So we type 1, enter, and follow the cursor. So then you put in -1, enter, and 2, and 0, and so on. I'll shut up. As soon as you get the last number in, and you press enter, put it in, press enter, then we have to second quit, right there in the top. The matrix menu is a little odd. You have, when you do something, you have to then get out of it and go back in. You can't stay in it. So once I get that matrix in, I second quit. There, so we're back at the home screen. Okay, so now I'm going to go back to matrix, second matrix. And the matrix you just put in is whatever your very top letter is. For me, it's A. Is it A for all of you? Okay, so press enter. And now on the screen, on your home screen, you should see A inside of a matrix. The matrix button is actually the inverse button. Don't second. See how it says X to negative first? That's your inverse button. Press it, not second it, just press it. And now it put a little inverse sign on your matrix. Press enter. And there is your inverse matrix. So that's the inverse. Not right. Well, okay, let's understand, it's operator error, okay? Because calculator gotta make mistakes.
So it's your measurement.
I know it, so that we still. I put
Okay. So Gavin got wacky answers, he did not get the same matrix we all got, because he input a number wrong into the original matrix. Make sure you're putting in the numbers that we did. Okay, so now some of you are thinking, okay, this is awesome, but why do I have an inverse? What does an inverse do for me? All right, so I'm gonna show you something now, all right? So everybody's back back on the home screen. Okay, the last thing on your screen was A inverse, right? Okay, so I'm gonna hit times. Just hit times. And then I'm gonna go back into second matrix and hit enter. I want to times it by A. Now what happened? What did you end up with when you took your inverse and you multiplied it by the original? You got all ones and zeros. You got what's called the identity matrix. You got what's called the identity matrix. So you know how when you multiply inverses with numbers, like when you multiply 5 halves times 2/5, they cancel. Inverse matrices cancel. This is the identity. We're going to do something with that in a minute. But first, let's finish up these problems here. D inverse.
Can't you not do it?
What?
You
Can't do it. Why not, Alexis?
Because you can't do a determinant of it.
You can't do a determinant of it. In order to have an inverse, your matrix has to be squared. Because that's the only way you can find the determinant, right? So D has no inverse. There is no inverse in D.
So can you ever work on a non-square matrix, like do anything with it?
Oh, you can do things with them, but, like we added and multiplied and stuff like that the
Yeah.
other day. But you can't do any of the special stuff with them, no.
Okay.
Not special.
All right, one more. And then we're going to do some work with the inverse. One more. Find an inverse. Okay, this is by hand. It's a little one. What, sir?
It doesn't have an inverse.
Why doesn't it have an inverse?
Because, they're both equal a minus a is
The
0.
determinant is 0. So Donovan, this is your problem right here, man. The determinant was 0, so we cannot find an inverse. There is no inverse to that. Okay? Now, I'm gonna do things a little out of order here since we have our calculators out. We're gonna solve this system. I'm going down to 7.0. Oh, by the way, 7.2 will be due on Thursday. And then 7.3, we're starting it here, and I'm gonna go down to number 2 first. I'm gonna do number 2, because it says do this on your calculator. And since we have them out, we'll go ahead and do it. So, what are we gonna do here? Well, the first thing you're gonna do is put a couple of matrices into your calculator. Yeah, but I need to make sure I copied that right, so that we end up with a good answer. Okay. So the first thing we're gonna do is put two matrices into our calculator. We're gonna put in another A matrix, just like we just did, that's why I was typoed it. And the A matrix is going to consist of the coefficients. So 1, 1, negative 3. See what I'm doing? 1, 1, negative 3. 2, 1, negative 1.
So it's gonna be a 3 by 3?
And 3, 1, 5. So it's gonna be a 3 by 3. Now wait a second, I gotta put in another one, so just hang on. That matrix goes in, it's called the coefficient matrix. Now, you're gonna put in another one called B, and it's gonna consist of the constants. So 7, 6, negative 4. All right,
A 3 by
so
1.
let's put them in. So second matrix, over to edit, enter. My A is 3 by 3, so 3 enter, 3 enter. And now these are the numbers, I'm just typing over the old ones. And then who remembers, what do we do after we get that last number in? Second quick. Now I'm gonna go right back in, second matrix. I'm gonna go over to edit, but this time you gotta click down to B. So click down to B and press enter. How big is this guy?
The big old one.
3 by 1. So 3 enter, 1 enter. 7, 6, negative 4. And again, as soon as you get that in, you're gonna second quit. So does everybody have both matrices in? To get the solution to the system, we're gonna multiply the inverse of A times B. And that's gonna give us the answer to this system of equations. So to do that, remember, we go back into second matrix. Just hit enter, that's A. Now you want its inverse, so you gotta press the inverse button. And then times second matrix, click down to B and press enter. And press enter. And did you get 3.5, negative 3.25? Is this what you got? And negative 2.25? So what does that mean now in terms of our answer? Well, that's X, that's Y, and that's Z. So if you use substitution or something, or elimination to solve that system, the answers would come out to be 3.5, negative 3.25, and negative 2.25. Okay? All right, let's see if you learned anything. Try the next one. Try B. It's exactly the same. The only difference is, what do you notice about some of those equations?
They don't have Y's.
Some of them are missing letters. How do you think I'm gonna handle that?
Zeros.
Yeah, exactly. You're gonna build it's gonna be the same size matrix. It's gonna be a 3 by 3, but it's gonna have some zeros in it. So it always helps me, I think of X, Y, and Z here, so then I know where to put the zeros. my coefficient matrix, okay, does anybody have a question about it? Everybody's okay with the numbers in there and the zeros and the ones and?
How are we rounding?
We'll talk about that in a minute. Let's switch up. Leave it there. Don't do anything to it. Just leave it for now. Is anybody stuck? After you get both matrices in, remember, then you have to tell the calculator to multiply A inverse times B. And then when you do that, it's going to give you a new matrix. But as Sir has pointed out, it's kind of ugly. Did yours come out ugly? Okay, so Sir said, how do I round? We're not going to round. Here's what we're going to do instead. On your calculator, you have a math button. See where I'm pointing right here? This little finger says math. Press it. First thing up there at the top is frac. Press enter a couple of times, and it's going to change those decimals into fractions. So did you get 46/27, 14/27, and 17/9?
So does that, could that be the inverse is 27?
You mean the determinant?
Determinant, yeah.
My guess is yes. It could also be a multiple of 27 if this happened to also reduce. That's a very high likelihood. So 46/27, 14/27, and 17/9. In other words, if we solved the original system of equations, we would end up with X, Y, Z. No. When you multiply it, that comes out as a matrix. What we're actually looking for is a point of intersection, but you put it together, it's the same thing. All right, so we're gonna go back and do the other ones by hand again, so you can set your calculators aside. We will be doing more work on our calculator for sure. Geometrically, what I want you to understand is, this problem, 2A and B, those are equations of planes. So in other words, like one of the equations is the front wall, and another equation is the ceiling, and another equation is the side wall. And what's happening is those three planes are coming together in a single point, like the corner of the room. You just found the corner of the room. Okay, well, that's impressive. All right, now we're going to do the same process, kids, but we're going to do it by hand. Oh, do I have to? Yes. On test day, you will be solving a system using the inverse method by hand. You'll also be doing that on your calculator. Okay? So I want you to think about what you did on the calculator, and now we're going to do it by hand. Excuse me. So the first thing we did was put into our calculator two matrices. Are you with me so far? That's what I put into my calculator. And then I told my calculator to multiply these two together. So what am I going to have to do? If I have to do this by hand, what am I going to need to find? I'm going to need to find the inverse. Well, good thing we know how to do that. Let's review it again. Who can tell me the first step my job now. I gotta find this.
You gotta do a determinant.
So I gotta find the determinant. So 1, 2, 3, -1. That determinant is going to be -7. Did everybody get -7? -1 minus 6. Okay, then, this is exciting. What do I do next? I'm gonna create this new matrix,
Once you flip the one in the negative.
kind of randomly, Ben. Remember how we make this new matrix?
Gabe? Oh, you're talking.
No, I'm not talking to you.
Yeah, I thought
I'm
you were
talking to
talking
Ben
about-
Cho. I know I call you Ben sometimes, I'm sorry for that, but I'm actually looking at Ben Cho. Remember, I switched these two? And it looks like I changed their signs. I didn't. I actually flip-flopped those two, and then I changed the signs on these. And then divide everything by -7. So my inverse is 1/7, 2/7, 3/7, -1/7. Is that all right with everybody? So now I know this. So to get my answer, I'm going to have to take that thing I just found and multiply it by my matrix B. This goes back to what we talked about before. Who remembers anything about matrix multiplication? Ethan?
So, wouldn't you do like 1/7 times 8 plus 2/7 times 8?
Almost, not quite. Remember, first I gotta check to see if I can do it. What are the dimensions of this guy? 2 by 2. What are the dimensions of this guy?
2 by 1.
2 by 1. The rule for multiplication is those have to match. And my answer will be another 2 by 1. So to find this spot right here, which is row 1, column 1, I write down my row numbers, and next to them, I write the corresponding column numbers. What do I get? 8/7 and 6/7. Remember, kids, when you multiply fractions straight across, so 8/7, 6/7. So that's 2. X is 2. And then how do I get this number? Row 2, column 1. So 3/7 and -1/7 times 3. 24 minus 3/7. 21/7, which is 3. I know exactly what you're thinking. Oh my gosh, Mrs. Ford, couldn't I just use substitution or elimination? Yep, you absolutely could have, except the directions say use the inverse method. So we're following the directions. Okay? All right, there's one more of those, luckily. So here we go. Everybody okay with this? I'm gonna erase and start over. Are you all right here? Everybody follow all that? Okay. Here we go. All right, so you're solving using the inverse method. So that means ultimately I'm going to do A inverse inverse times B. That's what I'm gonna do. So let's write down matrix A. Matrix A is 4, 3, -2, -1. And matrix B is 1, 6. Alright, so Caroline, you're busily working there. What are you writing down? What did you do next?
I solved it.
So she found the determinant. And so the determinant of my matrix A turned out to be what, Caroline?
2.
I think she's right. You really gotta keep an eye on your arithmetic here, but it's -4 minus -6. So her determinant was 2. Okay, then what did you do, Caroline?
And then I flipped the 1 and the 4 and the -1 and the 4, and then I made the signs different on the 2 and the 3.
Okay, so she built that new matrix called the adjoint by flipping and negativing and whatever. So that became, here I am, that became -1, 4, 2, -3. Is that what you got? And then you
Divided them by 2.
divided everything by 2. So her inverse, remember, to get our answer, we have to multiply the inverse of A times B. Whether we're doing it on the calculator or by hand, that's how you do it. So her inverse is -1/2, -3/2, 1, 2. And we're gonna multiply that times 1, 6. Okay? So here we go. Again, we're timesing a 2 by 2 times a 2 by 1. So our answer is going to be a 2 by 1. So we're going to take these two numbers and multiply them by these two numbers. It's always row, column. So -1/2 and -3/2 are getting times by 1 and 6. Do you get -19/2? Because it's -1/2 and -18/2. Now we'll take 1 and 2 and times them by 1 and 6. So that's 13. And there's the answer to the system. You need to be able to do that on the calculator and by hand. So do you feel like you can?
By tomorrow?
Huh?
By tomorrow?
No, not by tomorrow, but you should, I mean, we're learning it today, so yeah, technically by tomorrow, but you need to know how to do this by the time you take a test. Okay? Well, just when you thought you knew it all, we're going to do the same exact kind of problem, but we're going to do it another way. Okay, I need you to hang with me, guys. We have a lot of math to do. We get through these next two, I'll shut up. I'll be done. All right, but I want to get through these two problems using what is called Kramer's rule. All right, So the stuff that I'm erasing, when I do this right here, this is called the inverse method. Okay? The inverse method. So we have substitution and elimination that we talked about last time. We have the inverse method, and now we have yet another method called Cramer's rule. Cramer's rule, named for Gabriel Kramer, we're going to use nothing but determinants to solve this system. So we're going to come up with an x and a y, just like we have in the last two problems, 4 problems, whatever. We're going to come up with an x and a y, but we're going to do it with nothing but determinants. Step 1, find the determinant of the coefficients. So 3, -7, 2, 1. These are the x's, these are the y's. Find the determinant of that. That's exactly what we did when we did the inverse, right? We found the determinant. Okay, what is that determinant? 17. 3 minus -14, it's 17. That determinant is the denominator of your x and your y. So x and y are going to be fractions, probably, and their denominator is going to be 17. To find the numerators, you're going to build 2 new determinants, and it's really simple. I mean, the guy was brilliant to figure this out, but it's so simple. To find x, you're going to use a determinant. Cut out these numbers right here that we haven't used yet. Cut those out and paste them in the x spot. If you're solving for x, paste them in the x spot. So put 9 and -6. This is the x. And then leave the y's alone. So if I am solving for my x numerator, these numbers get pasted on top of the x coefficients. Well, then guess what I'm going to do when I solve for y? I'm going to paste them on top of the y. So I'm not rearranging anything. These are being pasted here. So I'm going to have 3, 2, and then 9, -6. And now evaluate. So what do we have here? 9 minus 42. What is that? -33? Is that okay with everybody? And then this one will be -18 minus 18. No, that's not 0. That's -36. And there's your answer to the question. Now, believe it or not, there are people, a lot of students, who if you give a choice, solve it. Substitution, elimination, or Cramer's rule. There's a lot of kids that will do Cramer's rule. And here's why. This problem wasn't rigged. Obviously, it got a bad, a yucky answer, right? Think about if you did this with elimination, let's say. If you eliminated, you would get x equals -33/17. And then you would have to do what with that -33/17? Plug it back in. It's okay, but it's a mess. It's fractions. It's yucky. We got a bad, yucky-looking answer here, but does it really matter? Did I have to do anything with those fractions? No. So that's why a lot of people like Cramer's rule, because the math is so easy. All right, one more, and I'll be done, I promise. Okay, so here's our system. We're going to use Cramer's rule. So what is the first thing I need to do, Grace? First thing I need to do. I'm going to find the determinant of my coefficients, 5, 2, 3, and 1. Now, back to Donovan's question. If that happens to be 0, it's not. But if it happens to be 0, we're done. Because this determinant becomes the denominator, right? Okay. All right, this one's not 0, though. What is this one? Oh yeah, this one's gonna be nice. So that means that my answer is going to be x is gonna be something over -1 and y is gonna be something over -1. To find my x, another determinant, but I'll cut these out and paste them right here on the x column. So I'm gonna have -7, 1, and then of course 2, 1 doesn't change. And then to do y, I'll do exactly the same thing, only they are gonna go here. So I'll have I'll have 5, 3, and -7, 1. Notice nothing's moving, right? They're just replacing. Okay, so what do I got here? -7 minus 2. I got -9. And then 5 minus -21. 26. Now clean it up. So your final answer is 9, -26. Nice work, folks.